Hello everyone, welcome back to this video lecture series on linear algebra. So in the first lecture we have discussed about column space and null space. In the second lecture we have discussed about rank of a matrix and system of linear equations, definitions and the working rule for the solution existence using the rank of a matrix. So in this lecture we will discuss that how to find the solution of the system of linear equations using the Gaussian elimination method as well as the inverse matrix method. So as I have already discussed about the working rule to find the solution of system of linear equations which can be converted to a matrix form Ax equal to B, where A will be the coefficient matrix, X will be the variable vector and B will be the right hand side constant vector. So using the rank we can see that the system is consistent, that means the solution is exist or not, or the system is inconsistent, that means there is no solution. And if it is consistent, then when it will have the infinite solution and when it will have the unique solution. So to exist the solution, the first rule is the rank of A and rank of augmented matrix, it is called augmented matrix, must be same. Now if the values is equal to the number of unknowns or number of variables, then it has unique solution. If the rank is same but it is less than the number of variable, then it has infinite number of solution. And if the rank of A and rank of A by B is not same, then it is inconsistent, that means no solution. So this is the rule. Now we are going to discuss one by one rule using some examples and how to solve it using the Gaussian elimination method. So suppose this is the system is given to you. So what is the rule? So first of all we will convert this to the matrix form. So 1 minus 2 4 2 minus 3 5 3 minus 4 and 6. This is the matrix A, that means the coefficient matrix. Now we will, along with the line and the right hand side vector, we have taken the augmented matrix which is A by B. Now our target is to find the rank of this total matrix as well as the left hand side matrix A. So this is A and the total is A by B. So we'll find the rank of this. So to find the rank we have to convert to row echelon form. So we'll use these operations. Row 2 is row 2 minus 2 row 1, because 2 minus 2 will be 0. So 2 into 1 2 minus 2. Similar way row 3 is row 3 minus 3 row 1. 3 minus 3 will be 0. So what you will get finally using these two? First row will be the as it is. So please remember you have to apply the operations on the total matrix, that means including the B also. So 2 minus 2 is 0, minus 3 plus 4 is 1, 5 minus 8 is minus 3, 3 minus 4 is minus 1, then 3 minus 3 is 0, minus 4 plus 6 is 2, then minus 6, sorry this is plus 6, sorry. So 6 minus 12 is minus 6, then 7 minus 6 is 1, right? Very simple. Now we have to find that this is the first pivot, this is the second pivot, the below elements of the first pivots are already 0. So you have to make this is 0. So 2 minus 2 can be 0. So R3 is R3 minus 2R2. So what you will get now? First row will be as it is. Second row will be as it is, no change. So 0 minus 0, 2 minus 2 0, minus 6 plus 6 0, 1 plus 2 3. Now please see carefully. Now if you see, what we will see, if you see the first pivot is this one, the second pivot is this one, but in the third row this one is the pivot, right? So if you see the only A matrix, that means up to this, if you see this, how many pivots you are getting? 2. So if you see only A, so 2 pivots, that means the rank of A is 2. But if you see the total matrix A by B, you are getting 1, 2, 3 pivots. So if we take A by B case, you are getting 3 pivots. So that means the rank of A by B is 3. So the rank of A and rank of A by B not same. One is 2, one is 3. So if these two are not same, it has no solution. Right? So the system has no solution. You can see this. So the system is inconsistent, it has no solution. So this is one example. Now take this one. Another example we have taken here. So this example, if you take the matrix, again 1, 1, minus 1, 3, 1, 3, 1, 5, this is 1, then 3, 8, 4, 17. So again we have to make this position is 0, this because this is the pivot. So we are going to use these three operations. Row 2 is row 2 minus row 1. So 1 minus 1 will be directly 0. Row 3 is minus 3 row 1. So this minus 0. So applying these two, what we will get? First row is as it is. So 1 minus 1 is 0. 3 minus 1 is 2. You are using the first only. Then 1 minus 1 minus 1, so 2. Now you are using this one. So row 3 is row 3 minus 3 row 1. So 3 minus 3 is 0. 8 minus 3, 5. 4 minus minus plus 3, so 7. Am I correct? So 3 minus 3, 5 minus 3, sorry 8 minus 3, 4 minus minus plus 3, so 7. So 17 minus 3 is 9. So second was 2, it is 9. Correct? So you are going to get this one. So the first, if you are using R2 minus R1, so 1 minus 1 0, 3 minus 2 1, 1 minus of minus 2, 5 minus 3 2. So R3 minus 3 0, 8 minus 6 is 2, then 4 minus minus plus 7, then 17 minus 9 is 8. Now you have to make, this is first pivot, this is second pivot, so you have to make these two is 0. So R3 minus 2 R2, so that means this third one. So you are getting here 3, here 4. Now if you check, so if I put the line here for better understanding. Now if you check only the A case, this part, so you have 3 pivots. So the rank of A is 3. Now if you take the total matrix, that also only 3 pivots, right? This will be considered in the total matrix also. So in the A by B also you are getting 3. So both rank are same. So both same means definitely solution exists. 100% solution is exist. Now question is that if solution exists, now it is unique solution or infinite solution. We have to check it. So you can check, you can count how many variables are given in the problem. So variable x, y, z. So 3 variables, or you can say unknown. So the ranks are 3 and number of variable also 3. So all are same. So rank also A, rank A by B, and number of variable all are same and 3. So that means it has unique solution. It has unique solution. Now how to find the solution of this? This is called the Gaussian elimination method. So Gaussian elimination method is saying that after the row econal form of the augmented matrix, you do the back substitution method. So if you see the previous, what we got, 1 2 1, sorry, minus 1 3, 0 1 2 2, 0 0 3 4. This was the augmented matrix. Now Gaussian elimination is saying that from here how to find the solutions. So if you take the A, so this is the A, so you will get 1 2 1, sorry, minus 1 0 1 2 0 0 3. Along with that you take the variables x y z. A into x equal to the B is 3 to 4. That means if you write in the equation format now, you will get x into 1 plus 2 into y minus 1 into z is equal to 3. First equation. From the second one you will get x equal to 0, that means 0, y equal to 1 plus 2 equal to z equal to 2. Now from the third equation, x 0, y also 0, 3 into z equal to 4. So finally you are getting 3 equations. You have 3 variables, you can easily find. So always do, according to the Gaussian elimination, always do from the back substitution. So from here we can easily find the value of z is 4 by 3. Now just substitute this here, z equal to 4 by 3. So you will get y equal to 2 minus 2z. That means 2 minus 2 into 4 by 3 is 8 by 3. That means 6 minus 8, so minus 2 by 3. Now you substitute this y value also. This is y value, this is z value. Substitute in the first equation y and z. So you will get x equal to 3 minus 2y plus z. That means 3 minus minus plus 4 by 3 plus 2 by 3. So this is 3, 9, 9 4 13 plus 2 15 by 3. So 5. Sorry, z is 4 by 3. Sorry. So if z is 4 by 3, so 9 plus 8, 17 by 3. So what is the final solution you are getting? The final solution you are getting, x equal to 17 by 3, y equal to minus 2 by 3, z equal to 4 by 3. So this is your final solution for unique. Why it is unique? Because the rank of A, that means the number of pivots in the row economical form in the A is 3, the total also 3, and number of variables also 3, x, y, z. That's why it has unique solution, and the solution will be calculated using the back substitution. That means x into 1, y into 2 minus 1 into z equal to 3. This is the first equation. 0 into x, that means 0 only, y into 1 plus 2 into z equal to 2, and the third equation 0 into x, 0 into y, 3 into z equal to 4. Now do the back calculation from the z. So first find the value of z, then put in the second equation, you will get the value of y, then put in the first equation of y and z value, you will get the value of x. So this is the finding the unique solution. Now if I take this another example here, so that can be, again the coefficient matrix will be 1 1 3. So 1 1 3, if we put the line here, so coefficient matrix 1 1 3, 2 3 minus 1, 5 7 1, along with the B 1 3 7, this total is called augmented matrix. So in the previous two examples, in the first example we have shown that solution is not exist because the rank was not same. The A matrix and the augmented matrix rank was not same. Now in the second example we have solved that both rank also same and the value is equal to the number of variables. That means it has solution and the solution is unique. Now we will discuss the next example. So again we are going to make these pivots below elements, that means this 2 and 5 is 0. So we are going to use this first operation, so row 2 minus 2 row 1. So 2 minus 2 is 0, 3 minus 2 is 1, minus 1 minus 6 which is minus 7, 3 minus 2 is 1. Now to make 5 is 0, we are going to use row 3 minus 5 row 1. So 5 minus 5 is 0, 7 minus 5 is 2, 1 minus 15 is minus 14, 7 minus 5 is 2. Now this is the first pivot. So this is the first pivot, below elements are 0. This is the second pivot. We have to make the below element is 0. So to that, for that we are using this operations row 3 minus 2 row 2. So 2 minus 2 will be 0. So 2 minus 2 will be 0. So you will get this one. So 2 minus 2 will be 0. Minus 14 plus 14 you will get here also 0. 2 minus 2 here also 0. So always put this line. Now if you see in the A case, here is A. How many pivots you are getting? 1 and 2. So the rank of A is 2. Right? And if you take the total matrix, then also rank is 2 because 2 pivots only, because in the last row all are 0. There is nothing non-zero element. There is no non-zero element in the third row. So you are not getting any pivot in the third row. So to total matrix also having 2 pivots only. So the total matrix, which is augmented matrix, the rank is also 2. Yes or no? So according to the rule, if ranks of both are same, then solution exists. Solution is exist. But if we see how many variables you have in the problem, x, y, z. So number of variable is 3. So that means the rank of A is equal to the rank of A by B, but it is less than the number of variable, which is nothing but 3, and these two are 2. So 2 is less than 3. So that means it is saying that solution is exists, but it has infinite number of solutions. So infinitely many solutions you have. So in this problem, ranks are same, but the value of rank is not equal to the number of variables, because the number of variables are 3, x, y and z. But here you are getting the rank is 2, which is less than 3. So that means its solution exists because ranks are same, but as it is less than number of variables, it has infinitely many solutions. Okay. Now question is that how to find the infinitely many solutions form. So if you write the augmented row econal form, what was the form? 1 1 3 1 0 1 minus 7 1 0 0 0 0. This was the row econal form of the augmented matrix, right? So again, according to the Gaussian elimination, we are writing the A matrix here into the variables x, y, z into the right hand side vector 1 1 0, right? So again, if you write the equation format, what you will get? So 1 into x, 1 into y, 3 into z is equal to 1. 0 into x, so 0, 1 into y minus 7 into z equal to 1, and here 0 0 0, that means 0 equal to 0, so nothing to write. So ultimately you are getting two equations. But I have already discussed that if you have number of variables is 3 and number of equations you are getting 2, so if you minus this 3 minus 2 equal to 1, this one variable will be free. So you have to take any variable of x, y, z is free. So if always take the last one, try to let z equal to k. So if z equal to k, so from the second equation you are getting y equal to 1 plus 7k. Now put in the first equation y and z, so you are getting x equal to 1 minus y minus 3z. So that means x equal to 1 minus y means minus 1 minus 7k minus 3 into z is k. So 1 1 is cancelled. So ultimately you are getting x equal to minus 7k minus 3k is minus 10k. So the final solutions you are getting here, the final solutions of the forms of the solution you are getting here, minus 10k which is x, 1 plus 7k which is y, and only k which is z. This is the solution set. K is any non-zero. Please remember this. In the non-homogeneous case, k cannot be 0. So non-zero scalar or constant. So why it is infinitely many solutions we are saying? Because if we change the value of k, you will get the different solutions. Like for the same problem, if you take the same problem, so in the solutions as I discussed, k is any non-zero constant. So if I take k equal to 1, so you are getting one solution, solution number 1, which will be x equal to minus 10, y equal to k is 1, that means 1 plus 7 is 8, z is 1. This will be one solution set. Now if you put k equal to minus 1 or k equal to 2 also you can take. So the solution 2 set will be x equal to positive 10, y equal to 1 minus 7 which is minus 6, z equal to minus 1. So you see this is different solution, this is different solution. If you put k equal to 2 you will get different value, 20, 15, 2. So that's why the system, this given system has infinitely many solutions, because you don't have the choice of k, you have infinite choice of k. So if we choose k value, non-zero value, positive, negative, fraction any, you will get for k different value, you will get different solution. So this is the concept of system of linear equation solutions. So what is the summary? I will just give a summary of this. So please always remember the cases for homogeneous and non-homogeneous. These two concepts are different. So we have two kind of system. One is homogeneous, one is non-homogeneous. So in the homogeneous case, what is the definition of homogeneous case? The system of will be looks like this: ax equal to 0. This right hand side is nothing but 0 vector, right? 0 vector means all the right hand side, all the elements will be 0. If a single element is non-zero, that will be not considered as a homogeneous system. That will be not considered as a homogeneous system. And in the non-homogeneous case, the looks like x equal to b, where b is not equal to 0 vector. That means in the b, at least one element is non-zero. Clear? So these two are the form of the homogeneous and non-homogeneous system. Now in the case of homogeneous system, if we take let the order of A is n cross n, and the rank of A is R, suppose. So it has two cases. case 1 and case 2. Case 1 is that if this rank R is equal to the order n, then the system has only trivial solution. What is trivial solution? Trivial solution means obvious solution, which is, I have already discussed, zero solution. Because you can easily see that if you put x equal to 0 vector, so A matrix into 0 matrix 0 vector will give you automatically 0 vector. So x equal to 0 is always satisfying. That means homogeneous system is always consistent. It has always a solution, which is trivial solution, zero solution. So if the rank of order is same, so it has trivial solution. And if rank is less than the order n, then it has, the system has infinitely many solutions. This is the concept of homogeneous system. Simple. Now if you see the non-homogeneous case, now in the case of non-homogeneous we have three cases: case 1, case 2, case 3. Case 1 is that if we write this A by B matrix augmented and the rank of A is equal to the rank of the augmented matrix, and this totally both are same and the equal value is number of variables. In that case it has unique solution. And how to find the unique solution? You just take the REF form, then do the back substitution. That means REF form, suppose this is the REF form 1 2 3 0 1 5 0 0 6, and here suppose 2 3 12. So you take x into 1, y into 2, 3 into z equal to 2, then this y plus 5z equal to 3, then only 6z equal to 12. Now find the z value here from this, then find y value from here, then find x value from here. This is the process to find the solutions. I have already discussed in this video 3 problems we have already discussed. You can watch it and you can understand the procedure of to find the solution. And the second case is rank same, that means solution exists but the value is less than number of variables. Number of variables you can easily count from the system, given system, or if system is not given you can find the system. I have discussed in the second lecture how to convert a problem to a system. Then you can easily count how many variables you have. So if the rank is not rank is same but value is less than number of variables, it has many solution, infinite many solution. The same process, you write the REF form, do the back calculation. If you are getting number of equation less, then take the variables as a free variable, that means take k1 k2 or if required only k. And the third case is rank of A equal to rank of A by B, sorry, not equal to, that means rank of the coefficient matrix and rank of the augmented matrix both are not same. In that case it is no solution, that means inconsistent. So to have a solution, ranks must be equal. The A matrix and augmented matrix rank must be equal. Now based on the number of variables it will be unique or it can be many, but rank must be same, and if rank is not same it has no solution. And for the case of unique solution and the infinite solution, for the both case, how to solve it using Gaussian elimination method, you have already the row econal form, because otherwise how can you calculate the rank. So use this row econal form and write in the equation form. That means first term is x, second term into y plus third term into z equal to the right hand side vector. Like that you write the equations and do the back calculation. For unique solution, you can easily find the value of first z, then y, then x. And if it is infinitely many solution, you have to take some variable as a k. If it is only one free variable, then only k. If two free variables, take k1, k2. And k can be any non-zero scalar, non-zero constant value. So this was the summary, and this was the concept of existence of solution of system of linear equations. So that's all for today, this lecture. In the next lecture, we will discuss the inverse of a matrix and how to find inverse of a matrix and how we can use this inverse to again solve the system of linear differential equation. So okay, thanks for the watching the videos. Goodbye.